Okay, ladies and gentlemen, so we are going to go through the existing examples in your notes. So I recommend to you that you try them first, then you watch the explanation. If you are struggling, you can come in and see me, but hopefully this will be enough to get you through this topic. All right? So step one is to take a look at what you are presented. You are given the oxidation states here. All you have to do is be able to interpret them. So magnesium is by itself, 0. Fe, literally read it. Magnesium, read it, 2 plus. Iron, 2 plus. So you are going to figure out which one is reduced. The one that goes down is reduced. Magnesium goes from a 0 to a 2 plus, nope. Iron goes from a 3 plus to a 2 plus. So as we write this reduction, we know that iron is reduced, and therefore magnesium is oxidized. So take your iron as it lies, Fe3 plus. You know you need to add electrons to it. You don't know how many, and it's going to end up as Fe2 plus. Now, how do I get from a 3 to a 2? That requires 1 negative, 1 electron. All right, so we're going to do the magnesium. Start with magnesium as it lies. Know that you are going to lose electrons oxidation. Therefore, your electrons will end up as a product on the product side, and you need to get to Mg2 plus. That requires 2 electrons. Notice right now that you have 1 electron and you have 2 electrons when you want them to be the same number. The number of electrons that magnesium loses should be the same number of electrons that Fe gains. So what you're going to need to do is multiply your iron by the 2 from the electrons so that you make sure that you have the whole same thing. Distribute, distribute, distribute. And we are going to then add it up. So you're going to take everything that's on the product side and everything that's on, well, this is the product side, everything on the reactants and product side, and keep them there. And you're going to write your final answer. So I'll write that below. We have F2Fe3 plus 2E minus plus Mg yielding 2Fe2 plus 2E minus plus Mg2 plus. You can now notice that you can cancel your electrons and fill in your coefficients up here. 2 Fe, 1 Mg, 1 Mg, 2 Fe. All right, so try number 2 on your own, and when you come back, I will give you the answers here. All right, your aluminum is going to be a 0. Your Ti is listed, your second aluminum is listed, and Ti is 0 at the end. We have the oxidation states. We know that the reduction is going to be the Ti, and the aluminum is going to be oxidized because its number is going up. So I'm going to start with the Ti. So Ti, and it's a 4 plus. I know I need electrons on this side. They are gaining them. Gain electrons reduction. And I'm going to end up as Ti 0. That means I need to have 4 electrons. My aluminum starts as aluminum 0. It's going to lose electrons from aluminum 3 plus 3E minus. Immediately you notice 4 and 3 are not the same. So what we're going to do is multiply the Ti by 3 and the aluminum by 4 so that we will get a total of 12 electrons in both. Greatest common factor, basically, or common multiple, or whatever you want to call it in math class. So then we're going to add them up once we've distributed. Okay? So ultimately, I will get 3 Ti 4 plus 12E minus plus 4 Al yields 3 Ti plus 4 Al 3 plus 12E minus. You'll check that everything is balanced, cancel your electrons, and copy over your coefficients. So 3, 3, 4, and there's no place for that 4, but it belongs there. We're going to skip number 3. It's not tested. Don't waste your time or energy. Alrighty, so See if we're in the right spot. Alrighty, so if we take a look at this guy, again, oxidation numbers listed, 0, 2 plus, plus 1, and 0. Our reduction is going to be our Ag, goes down, oxidation is going to be the Cu. So we take our Ag plus 1 E minus, yielding AgO. Our copper goes from a copper to a copper 2 plus, therefore we need 2 E minus. Okay? We are going to multiply the aluminum by 2 and distribute that through. So on each of your silvers, you will get that 2 coefficient, and your copper will get the 1s. Not too bad. Number 2, hopefully, again, reminder, do these yourself and then check your work. Okay. We are going to get 0, 3 plus, 2 plus, 0. So therefore, the Pb is being reduced. The Fe is oxidized. Pb, 2 plus is what you start with, plus 2E minus, yielding Pb 0. Oxidation is Fe, meaning that your electrons need to be on the opposite side, Fe 3 plus, plus 3E minus. In this case, we are going to multiply through by 2 and by 3 because our electrons are clearly not equal, and we are going to get a total of 6 electrons. So I will get 3 Pb 2 plus 6E minus plus 2 Fe yields 3 PbO plus 2 Fe 3 plus 6E minus. Now we have 6E minus on this side and 6E minus on that side. Okay? So we can cancel out our electrons and we can copy over our coefficients. So we have 3 and 3 and 2 and 2. Alrighty, on to the next couple. Whoops. Let's undo that one. Okay. So for the silver and the chromium, silver is going from a plus 1 to a 0. Chromium is going from a 0 to a plus 3. So the chromium is being oxidized and the and the silver is being reduced. So we are going to go Ag plus 1 plus the 1 electron necessary to get us to an Ag0. Our chromium Cr, if it is being oxidized, Leo, meaning it will lose electrons, and I will have 3 electrons that are lost. We are then going to balance. Silver needs a 3. Distribute to each. And notice you'll get an even 3 electrons. You will add it all up. Keep on this side, keep on this side. And then you'll ultimately get 3s on your silvers and 1s on your chromium. All right, number 4, last one. Let's go step by step. Step 1 is to get your oxidation numbers. Plus 1, 0, plus 1, 0. Figure out which one is reduced. Which one goes down? That will be our nickel, therefore our lithium is oxidized. Begin with your reduction. Take that metal or element as it lies. Ni plus 2. Know that you want some number of electrons and you're trying to get back to Ni0. Balance your charge. You need 2 electrons to balance it. Your lithium, take it as it lies. Li0. Know that you need to get to Li plus 1, and you need 1 electron to make that happen. Gur and Leo. All right, if you notice your electrons are uneven, as they are here, multiply to get them to be even. Your lithiums will then have a 2 coefficient. Your nickels will have a 1 coefficient. All right, and the last question that we have on here is a bit of review of Table J and what we did today. So the structure of the Statue of Liberty is made of copper metal. the framework is made of iron. Over time, a thin layer, a patina, forms on the copper surface. So, when copper is oxidized to form this patina, copper atoms become copper 2 ions. That's this, copper 2 plus. Write a balanced half reaction for the oxidation of copper. So that means we are taking copper, we are losing electrons oxidation to form Cu2 plus 2E minus. Now, where the iron framework came in contact with the copper surface, a reaction occurred in which iron was oxidized. Using this, explain why the iron was oxidized as opposed to the copper. Okay, use Table J, figure it out. Hopefully the answer that you come up with is Fe is more active and therefore more easily oxidized. All right, thanks for watching. If you are still confused, please come and see me. Please, please, please come and see me. 10th period.